All right, so we are at the top of the hour, and thank you for joining us today. My name is Jacob Hayden, and I'm the program coordinator for SaferSim at the University of Iowa. SaferSim is a Tier 1 university transportation center with the research priority of promoting safety. And our webinar series features the research projects from within our center. So thank you for joining us today. There will be time at the end of the presentation for questions and discussion. Um, so I think we're all familiar with Zoom now. So if you have any questions or comments, attendees can use their microphone at the end. And feel free to use the chat box throughout the presentation at any time if you have a comment or question. We will save those comments or questions till the end though. So today's webinar, it features a research project from the University of Puerto Rico, Mayaguez, and I'm pleased to welcome our presenters, Dr. Carla López del Puerto and Dr. Didier Valdés.
I'm Carla. I'm here with my colleague Didier, and this is a research that we did with Dr. Alberto Figueroa Medina and Dr. Benjamin Colucci Rios, and with two of our graduate research assistants, Edgardo Concepcion and Lorena Sierra. So we're going to be talking about driver safety assessment in two-lane rural roads. You can see a picture of us here. Next. So here's our agenda. We're going to do a brief introduction. We're going to talk about our research objectives, our hypothesis, and we're going to discuss our experimental design, the points and zones of interest, the results and the analysis of the results, the conclusions, the recommendation, and finally, we'll include the acknowledgements. Next. So as all of you know, having a safe and efficient transportation system is essential for both mobility and accessibility of both person and goods, and also to foster socioeconomic growth in our country. But sometimes to maintain an efficient transportation system, we need to perform construction work, maintenance and repair activities, and oftentimes we're unable to close those roads to traffic. So when that occurs, we have work zones. A work zone is a temporary closure of a zone of an in-service highway where repairs are made with workers and vehicle present. So they pose a series of challenges that we need to address. Looking at a study from 2018, statistics from 2018, we found that 672 people were killed, out of which 125 were construction workers. So both the traveling public and the construction workers are at increased risk of fatalities and injuries in construction work zones. So we need to protect everybody in and around the work zones. Next. Okay, so how do we protect when we're unable to close the roads to traffic? Well, we use appropriate signage, markings, and other traffic control devices. And the goal is to provide positive guidance to motorists for safety travel along the work zones so that we protect both workers and the traffic from serious injuries and fatalities. So, as you know, traffic control plans are a combination of signs, markings, and traffic controls, which are designed to assist travelers cross the work zone safely and efficiently. So our goal in this research was to look at a work zone and analyze it. The MUTCD defines a TTC zone as an area of a highway where road user conditions are changed because of a work zone, an incident zone, or a planned special event through the use of TTC devices, uniformed law enforcement officers, and other authorized personnel. So it's very important to look at these traffic control plans in the work zones. Next. Okay, so we need to study road user behavior in the work zones to see what is contributing to these accidents. We looked at previous research, and it has shown that the changes imposed by the work zone when we have operating conditions or the roadway alignment increase the driver workload, which results in a higher risk of crashes and a higher severity of crashes. And previous research has found that there are several factors that contribute to these behaviors, and it's speeding behavior, use of smartphones, which is what we're going to be focusing on our study primarily, braking maneuvers, and the vehicle trajectory. So we're going to be looking at all these contributing factors to analyze in our work zones. Okay, so as everybody knows, smartphones are commonly used while driving. Over the last decade, the amount of people or the percent of the population who has access to smartphones has really increased. And it's one of the main concerns in and around work zones where operation and maintenance activities are being performed because they lead to driver distraction. In particular, drivers use applications such as GPS when driving through a work zone. So we're going to be looking at the use of GPS through work zones, and we're going to be looking at how the behavior of drivers is impacted by these smartphone applications. Next. So this slide talks about illegal restrictions in Puerto Rico for using smartphones. And in summary, what it says is that the use of smartphones while driving is prohibited by law, except on some very punctual circumstances. So they can use it in hands-free mode, or they can use it in when they're calling emergency services or enforcement agencies, and when there's a medical or safety situation, and it defines what those situations are. So there are situations that pose an immediate risk to health, life, or property. And it also says that the law does not apply to drivers in official vehicles that are attending emergency situations. So it's very clear when we can and we cannot use smartphones. We did a previous study where we asked respondents whether or not they were using smartphones, and the vast majority of respondents indicating that they do use smartphones for GPS, for texting, for social media. So it's very common to use smartphones while driving. Next. So our objectives is to evaluate if GPS significantly varies the potential safety implications associated with serious injuries and fatality. And we're looking at two things primarily. We're looking at destruction caused by audible messages on an active GPS while approaching or entering the advanced warning area of the TTC. So we're simulating a GPS in our scenarios. And we're also looking at the probability of driver error maneuvers when approaching the stop slow instruction that our flaggers provide. So those were our two main objectives. Next. And our research hypothesis is that when drivers are subjected to a driving distraction, so a navigation task in our case, when transmitting a work zone, they will exhibit worse performance, in other words, unsafe behavior than those who do not have a distraction while driving. So we're comparing drivers who are using GPS for directions to drivers that are not using GPS for directions. And they're driving along the same two-lane road work zone. So basically what we're trying to do is looking at uh, two scenarios, one with GPS and same scenario without GPS, and see if their performance is unsafer when they're driving with GPS. Next. So we look at, we did a lit review, and we uh, found that a study by State Farm indicates that even though drivers are aware of the dangers of using GPS, a large number of drivers still engage in the behavior. And we also found that using smartphones while driving has negative effect on several actions, including reaction time to an event. Drivers distracted by having smartphone conversations uh, take 22% longer to detect an event in their peripheral vision. That's what one study found. Another study found related to braking aggressively that drivers distracted by having smartphone conversation brake more aggressively compared to non-distracted drivers to reduce initial speed when an unexpected situation appears. Related to longer perception and reaction time, we found that drivers tend to be more distracted by smartphone conversations, and they take longer to react. Uh, they also do unconscious time compensation. Bellinger concluded that distracted drivers use an unconscious time compensation with a faster movement to the brake pedal, resulting in more intense braking deceleration. And finally, slower response and more intense braking when performing dual tasks. So they found or identified a lower response and more intense braking. So these are all negative effects that are caused by smartphone distractions. So next.
Okay, thank you very much, Carla. Thank you for this part of the presentation. Let me introduce you then to the study per se. We selected the Puerto Rico 108 is state highway, two-lane roadway in Mayaguez, a rural road, one lane per direction, and approximately average daily traffic of 19,000 vehicles per day with a speed limit of 35 miles per hour. We use a segment of 1.8 kilometers. And you can see here at the left a sketch of the plan view of the whole segment, and then highlighted to the right these two figures, each one of them for each of the work zones that were considered. As you can see, we have all the signage corresponding to the signage required for the MUTCD. And in both cases, we have one lane closure for the job that was performed there. So what was expected from the drivers was to stop when they arrived at the work zone because the lane was closed, and then wait until it was safe to change to the next lane and use that lane to travel along the work zone and to the other side of the work zone. So the same thing happened in both of these work zones. Um, we also have another variable, which is another factor, which is the flagger. So as Carla was saying, we have the GPS factor with GPS instructions or without GPS instructions. And we also have the flagger factor, which is say, some scenarios with a flagger and other scenarios without the flagger. And these are conditions that occur in our system. No, we may have one one work zone but no flagger, or just one flagger for both directions, something like that. In this case, we are using this approach just to make sure that we have all the factors considered. Now we have 24 subjects, and also um, the dependent variables, the mean speed, deceleration, speed variance, the reaction time, lateral position, usual dependent variables, and also all those variables were measured for the different sections of the work zone. Now, here you can see in a minute, let me see what is the video. Here we go. This is a short video of the scenario with flagger and no GPS. Mhm. Okay, the vehicle arrives at the work zone. It's a little bit jumpy for the internet speed, sorry. And then you have the flagger. The flagger was always exhibiting the stop sign because there was traffic on the other lane. So once that traffic cleared the way, the flagger will switch to proceed with caution. So it was expected that the driver would stop right there before entering the other lane. So, and this was also expected even if there was no flagger, so that the driver should stop and take a look at the road, and then once it was safe, then proceed. Well, now let me show you some figures and our conclusions and recommendations. Well, first, let me show you the average speed figures that we have here. In this case, this is the average for each one of the scenarios. And as you can see, the vehicles start gaining speed, and then they will go more or less at 35 miles per hour, which was the speed limit. Then when they arrive to the work zone, of course, they stop. Some of them, as you will see in the next slide, you will see that some of them stop, but some of them not. So when we average them out, this thing happened that the speed really doesn't go to zero. So this was one very, very important thing that we found. Now, these are the individual speed profiles. As you can see here, the scenario, for example, scenario one is with the flagger. In this case, all the vehicles stopped at one point previous to the work zone. This is the first work zone. All they stopped. Some of them really didn't stop completely, but most of them stopped. However, scenario two, without the flagger, then we had some various vehicles that really didn't stop at all. They just continue, and we will see what happened with them. Unfortunately, in scenario three, which is similar but with a GPS and flagger, some people may have gotten distracted and continue even though there was a flagger, as you saw in the previous video. And similar things happen in the scenario four. These two graphs show the the percentage of drivers that encroached and crashed. And what happened here is that you have the order of the runs. People run each one of the scenarios 4 times. So we have the first time the driver faced that situation, you have 54% of the drivers in the first work zone didn't stop. They just keep on going. And even in the second work zone, 35% of those drivers continued. So this was a very dangerous behavior. And actually, as you can see here in this other graph to the right, 38% of them, the first time that they run the scenarios, crashed with the vehicle in the opposite direction because the scenario was simple. We didn't have the oncoming traffic stopped when there was a vehicle there. So they just passed them through because there was a crash in that case. So we have this kind of situation. However, they learned the behavior, and then in the subsequent runs, they changed their behavior, even though there were still some percentage of drivers that keep on doing the same thing. Now, in terms of the decision to encroach, so what happened here is that the work zone was active in the in front of the exit that the driver would have to take, and the GPS was telling the driver, well, exit at this street, exit at this street. However, there was an active work zone, so, and it was very well marked, so they should have continued. But they didn't. Some of them didn't do it.
So basically what we found is that in the scenarios where they had an active GPS, 50% or 2 out of the 4 audible messages, what they instructed subjects was to encroach the workspace, which obviously was closed. So they had to decide whether or not to follow GPS instructions. Of course, if they followed GPS instructions, they created a hazardous situation. And 25% of those subjects decided to encroach the work zone. So in other words, they created a hazardous situation. When there was a flagger present, the subjects made a full stop when they reached the construction zones, but when there was no flagger present, 8 out of the 24 subjects continued straight without stopping. So what it shows is the positive impact of having a flagger on site, and the hesitation of deciding what to do. So they hesitated when they encountered the unexpected situation, generated dangerous behavior for both drivers and construction workers, which indicated that our intent, which was to assess whether the GPS and the hesitation caused by contradicting instructions through the GPS it reached our intended intention, which was to see whether or not it impacted driver behavior.
I think the main recommendation here, very quickly, is that coordination is very important between the agencies that are performing work in our highways or freeways in the previous study, and then with the companies that provide information. I think that's the main recommendation here for providing the correct information, even with mobile work zones or work zones that are temporary or something like that. So that's important. And the other thing is that the GPS is actually a distraction, and it may cause troubles for drivers and also for the workers. So I believe that the other main recommendation is that this kind of work zone behavior needs to be reinforced uh, also in for the new novice drivers when they are taking their exam at the beginning, and also when renewing licensing and all that, because it's something that is important for drivers and for the life of the workers as well. So thank you very much. And of course, Safer Sim is the main sponsor of this research. And thank you. With that, if there is any question, I think we have a minute or something.
I do just want to say too that this presentation will be available online in the next couple of days, so we'll share that with people that registered, and feel free to share that link with anyone else that you think may be interested. And then we do have a break between now and our next Safer Sim webinar, which will be on Tuesday, April 20th, and that will be a research project from the University of Massachusetts Amherst. Um, so with that, I think I'm not seeing any questions. I think this is really interesting work, and I think that I know the work zone safety is a big issue for us here in Iowa, and I think this is a really important topic to be looking into. So I think with that, we can end it there. Again, thank you, Carla and Didier, and we hope to see you at future webinars.
Thank you very
Okay,
much.
thank you, Jacob.
Thanks. Have a good one.
Thanks. Bye.